Okay, for this case, I can write velocity of, for example, B, velocity of A is equal to, by definition, I can write this is dRA dt. Or velocity of B, which is vector, is rate of change of position vector with respect to time. That is absolutely correct because that is the definition. No further argument. Okay, because it is rotating, assuming that this is the center of mass, and assume that this is rotate like that. Our ultimate goal is to how to express this vector. We just say this is rotating in this direction, and we want specifically describe this is rotating in this direction. Okay, then this is, I observed from this picture, BARAB.
변화율이 0인 거 아닌가요? 저거 R 자체는 항상 있는 거 아니에요?
Ah, yes, he is correct. Wow, that is my mistake. You are correct. Oh, thank you very much. And this is, I call, let's say this is RA prime, if you like. Okay, then the velocity at tip can be expressed, velocity at tip can be expressed, what? If I denote this is E theta vector, and this is ER vector, then I can write this expression, remembering what we have in previous chapter. I can write this is D dt and RA, magnitude RA prime multiply ER vector. Okay? If RA vector, magnitude RA vector is constant, then I only have RA magnitude multiply the rate of change of this vector. And what is this? That is change of this vector, meaning that if it rotates like that, the ER vector will change like that. Therefore, the change of this vector would be this vector collinear with the E theta. So I can write this is E theta vector, indicating the direction of velocity. That makes sense. That is same as real physical intuition. And what is this? Sorry. What is this over here? That has to be the rate of change of angle with respect to time. Okay? That we call omega, because omega is rate of change of angle with respect to time. And we call omega E theta is equal to omega vector. Therefore, I can write this is the RA prime magnitude and omega vector. And I can write VA vector is equal to DRA vector dt, and that is equal to omega cross product RA prime vector. Okay, let's see the direction of this two vector. Omega vector is something in this direction, omega. Okay, omega has this direction, cross product of R vector. So omega cross product RA vector in this direction, therefore it has this direction. So that indicates the direction of E theta vector, and the magnitude is R multiplied by omega. That is angular velocity. And it is so obvious in this case, because the moment the arm is RA, and it is rotating with the omega, therefore the velocity of tip should be R multiplied by omega. But essential message I'd like to give you is omega is a vector. We can express omega as a vector. Omega is a vector. Vector. That makes everything compact and easy, but in the beginning that makes you so puzzled and will sometimes give you a headache. And another thing, let's see. Here is a bar, and the bar is rotating like that. Let me draw. Please concentrate. This is very important. I have a sphere, two spheres, and this sphere moves down over here. Therefore, it will reach over there with a certain velocity. Okay, I can say the motion of this is the same as, okay, this one move down, therefore it will move down over here, and then it rotates with omega so that it reaches over there. Okay, I decompose the motion of this into pure translation and rotation. And also you could say, oh, no. I can say this will move that way, therefore it move that way. And then rotate like that. This will produce the same terminal position. That is good. That is correct. So the message from this illustration says turning, rate of change of turning is omega. Of course, this is omega too. And if you look at those omega, it's the same direction because it has this direction. And the magnitude of that omega turns out to be same. That means the omega vector on this plane is the same whether I rotate this or I rotate that. It's the same whether I rotate with respect to that or whether I rotate with respect to that, whether I rotate with respect to that. Now you can see that, right? So omega vector is independent upon the location of selected plane. So you can apply omega vector in any way on the plane you select. That's the very important message I would like to give you in this lecture. Okay, see you.